Welcome. You found your way to a quiet place, a corner of the night where we move more slowly and let the noise of the surface world fade. This channel is a shared vessel for calm journeys into the deep ocean, into hidden layers of our planet that most of us will never see but can still imagine. Stories shaped by depth, pressure, time, and long stretches of silence. And if you'd like to return to this place again, a quiet like or subscription helps keep these slow journeys afloat. For now, make yourself comfortable, and let's begin our descent. Tonight, follow me not into a fast, fact-heavy lecture, but into a calm, contemplative journey. You do not need to remember numbers or names. You can simply let the idea of this deep, cold underworld wash over you, the way waves slide quietly under the ice shelves themselves. If you like, you can imagine the faint creak of ice above, the slow swirl of supercooled water below, and, somewhere in that darkness, small forms of life clinging to the underside of the ice, filtering what little the ocean brings them. What lies beneath these floating edges of Antarctica is, in many ways, more inaccessible than some of the places we send spacecraft to in deep space. Not because it is farther away, but because Earth's own ice, its own moving, shifting glaciers, stand between us and that hidden ocean. We've mapped the surfaces of distant planets in more detail than the seafloor under these shelves. So as you settle in, and the night gathers a little more closely around you, we're going to lift that frozen ceiling in our minds and step, very gently, into the world below. A world we can stand on, but hardly touch. So, follow me a little further into this cold, quiet place we're imagining together. And make yourself comfortable with a very simple picture. We often picture Antarctica from above, a flat, endless sheet of white flags, snapping in a dry wind, a few scattered research stations with their bright metal towers and fuel tanks, a line of tents half buried in drifting snow. It feels solid, almost reassuring, like a frozen continent you could cross if you just had enough time and warm boots. But now, picture what happens when we gently peel that familiar surface away in our minds. Much of what we call Antarctica at the coast is not land at all, but floating ice shelves, vast slabs of glacier ice that have flowed off the bedrock and spread out over the ocean like a frozen skin. Some are hundreds of meters thick, some push past 1,000, a vertical stack of ice taller than most city skyscrapers, yet they ride on dark seawater that can reach far inland beneath them. We are standing, quite literally, on the roof of a hidden ocean. On top, life feels possible. We can pitch a camp, bolt instruments into the surface, land aircraft, drive heavy tractors in slow, careful lines. People have lived for months at a time on the Ross Ice Shelf, on Filch Narone, on the edges of Thwaites, cooking simple meals, repairing generators, watching the same pale horizon for weeks. The snow crunches underfoot, radios crackle, flags mark safe routes. It feels, in a quiet way, like we have claimed this place. Yet just a kilometer beneath those boot prints, almost nothing we do can reach. The water under an ice shelf is not a cozy underfloor lake. It is a deep black cavity where seawater brushes and melts the ice from below, where the pressure is immense and the ceiling itself is slowly moving. We can drill down with hot water, lower a camera or a small robot-like ice fin into that narrow shaft, and let it swim for a few hours through this world of creaking ice and supercooled currents. But often the borehole begins to refreeze behind it. The ice flexes, the tether snags, sometimes the machine never comes back. So we arrive at a strange paradox. We can stand, walk, sleep and work on this surface for years, but the space directly beneath our feet remains almost untouched, barely mapped, and in many places, effectively unreachable. Not because we lack curiosity, but because the Earth here quietly resists being opened. In the rest of this journey, we're going to slow your thoughts and look more closely at how these hidden spaces actually work. Why this buried ocean matters for coasts an ocean away, and why, even with our best tools, the deep world under Antarctica's ice shelves still keeps most of its secrets. Where are you listening from in this vast cold story? So before we sink any deeper into that hidden ocean, let's pause for a moment and notice something very simple. You, where you are, and how this vast cold story is reaching you right now. Are you listening from bed, maybe with the room light dimmed and the glow of a screen the only small star in your ceiling sky? Or are you folded into a couch, half wrapped in a blanket, the day finally loosening its grip on your shoulders? Perhaps you're at a desk in the middle of a late-night study session, notes open, mind wandering just a little, or moving quietly through a commute, the world outside your window sliding past in the dark. Wherever you are, make yourself comfortable. Let your body notice the details we usually ignore. The weight of the blankets on your legs, the warmth gathered under your sweater, the cool patch of air on your face, the gentle pressure of the chair or mattress beneath you. Feel the small human climate you've built around yourself, this tiny warm place on the surface of the Earth. Now, picture what happens if we gently lift that comfort away and set it beside Antarctica. Under its ice shelves, the seawater is just a breath above freezing, sometimes slightly below, salty enough to stay liquid while the cold presses in from every side. It moves slowly through black corridors under hundreds of meters of ice, touching the underside of the glacier the way a tide touches a cave roof, year after year, century after century. We often picture cold as a sharp, sudden thing, a winter gust, a handful of snow, the shock of stepping outside without a coat. But the cold beneath these ice shelves is different. It is patient, steady, and very old, a deep chill that has wrapped itself around this part of the world for longer than our cities have existed, longer than our languages have had words for it. Above, storms come and go. Below, the darkness barely changes. So as you feel the softness of your pillow, or the gentle sway of a train, imagine that directly under the Antarctic surface there is a ceiling of ice as thick as a skyscraper as tall, and under that, a black sea that has never seen the sun. Warmth here, almost freezing water there, a lamp on your nightstand, and under the far pole, a world lit only by faint glows from drifting life and the slow creak of moving ice. If you'd like to help keep this small, quiet space going, this place where we're going to take long, slow journeys into hidden corners of the Earth, you can tap like or subscribe, or leave a gentle comment about where you're listening from. It's a way of saying, yes, more of this, more time to slow your thoughts and follow me into these deep stories. But it's never required. The real invitation is simply to stay with the sound of the words, to let your attention rest wherever it wants, and to keep drifting with us under the ice, as we turn next to the strange shapes and secret movements of the world beneath Antarctica's shelves, letting your thoughts drift southward. So, as we keep drifting with those secret shapes and movements, this is a good moment to make yourself comfortable in a very literal way. If you can, adjust your pillows or your chair, let your shoulders sink a little, maybe soften your jaw, and allow your breathing to lengthen into something slower and quieter than the day ever really allowed. We're going to treat this like a long, gentle voyage, not a sprint, so there's no need to hold yourself upright in attention. You can let the weight of your body settle while you let the weight of the world, for a while, go. As you do, you might notice that when the body softens, the mind often follows, and it becomes easier to slow your thoughts, to let them stretch out and wander without needing to arrive anywhere in particular. Now, if you're ready, follow me in your imagination, not sideways through your day, but downward across the globe itself. Imagine the Earth as a dimly lit sphere turning under your feet, the familiar shapes of your own continent sliding past, then the oceans, then the long curve of South America, the scattered islands of the Southern Ocean, all drifting slowly toward the bottom edge of the map in your mind. We often picture that bottom as a blank white circle, a kind of empty margin where the real world simply stops. But as we keep moving down, further and further into the cold, that white ring at the base of the planet, begins to sharpen into something else, a vast fractured collar of ice shelves floating on black water that reaches deep beneath them, some of them hundreds of meters thick and stretching hundreds of kilometers out from the land. Somewhere along that edge lies the Ross Ice Shelf, broad as a small country. Somewhere else, the Filchner Rhone and the more fragile shelves that guard West Antarctica, places where warm, deep water creeps in under the ice and quietly eats it from below. These shelves are not just scenery, they are corks holding back the giant glaciers and ice sheets behind them, deciding how much frozen weight the oceans can bear before sea level must rise. And all of this has been unfolding for tens of thousands of years, through ice ages and brief warm spells, through times when no human eyes had ever seen this part of the world. Under that floating ice, the seafloor is carved into hidden mountain ranges and deep basins. The water is squeezed by pressure and darkness, and strange currents trace paths we are only beginning to understand. So Antarctica is not a blank void at the edge of the map, but one of Earth's last great frontiers, especially in the shadowy spaces beneath those shelves, where the ice lifts off the rock and begins to float. The surface, the white we see from satellites and postcards, is only the roof. The real story of this place begins where that roof first separates from the land, opening a thin, secret doorway into a cavernous, unseen ocean that we have barely, and only very recently, begun to enter at all. The illusion of endless white. The roof from above looks so simple. A clean white sheet, a quiet line where ice meets sky, as if the whole continent were just a single frozen thought stretched out to the horizon. We often picture Antarctica this way: flat, blinding, empty, a cold blank page where only the occasional dark mountain or a small cluster of penguins breaks the stillness. If you let yourself slow your thoughts for a moment, that image can feel almost peaceful. The wind skims over a hard, polished surface. Snow grains whisper along the crust. From a satellite's eye, the ice shelves seem like calm platforms, smooth and featureless, gently floating at the edge of the world. It's easy to believe that what you see at the surface is what continues straight down, one uniform slab of ice, simple and solid, resting on a quiet sea floor. But that is an illusion. Beneath that calm white lies a landscape as rugged as any mountain chain on Earth, and in many places, far stranger. Follow me in your mind's eye, straight down through the ice. The flat plain you imagined breaks apart into buried ridges and deep basins, into valleys carved by ancient glaciers long before this modern ice sheet existed, into hidden mountain ranges whose peaks never see the open air. Radar pulses sent through the ice, echoing back over years of patient surveys, have drawn ghostly maps of this buried world, showing trenches deeper than the Grand Canyon and basins that could swallow whole countries. Now, picture what happens where that ice begins to float. The shelves themselves are not solid tables, but fractured ceilings hanging over a black ocean. Their undersides are scalloped and rough, sculpted by currents that thread through in the dark. Warm, deep water creeps in along the seafloor, rises under the shelves and eats at them from below, carving long melt channels, overhanging ledges, and knife-edged ridges of ice that no human eye has ever seen directly. In those shadowed spaces, the vocabulary of the hidden world grows richer. There are grounding lines where the ice finally lets go of the rock and becomes a floating body. There are subglacial rivers, thin but persistent, carrying meltwater from far inland, pouring into the under-ice ocean like invisible waterfalls. There are roofed canyons and broad cavities, some large enough to hold entire cities, where the pressure is immense and the water is always just at the edge of freezing. And even here, in this cold, sealed place, life seems to find a way to wait. On rare occasions when we manage to drill a narrow, carefully sterilized hole and lower a camera, we glimpse things that feel almost impossible. Pale microbial films clinging to the underside of the ice. Strange filter feeders rooted to a boulder far from any known source of food. delicate sediments recording thousands of years of quiet change. All of it lies behind a barrier that is both simple and absolute. Hundreds of meters of ice, crevassed, shifting, flowing outward year after year, form a moving ceiling that locks away the world beneath from sunlight and from easy access. That's what a glacier is at this scale. Not just frozen water, but architecture, a living roof that flexes and groans while the ocean breathes below. We're going to spend the rest of this journey trying to understand how that restless roof controls what happens in the darkness under it, and why even touching that darkness without disturbing it is so hard for us to do. Standing on the roof of a black ocean. So now, follow me from that living roof down to where we almost never get to stand, at least not in any ordinary sense. Imagine you are out on one of Antarctica's great ice shelves, a flat white horizon in every direction, the air so still that you can hear the soft hiss of your own breath inside your hood. The only movements, the slow drift of snow grains and the distant, muffled creak of ice shifting somewhere far away. On that surface, it feels simple, just wind and cold, and light reflecting off ice until the world seems almost empty of detail. We often picture Antarctica exactly like this, a clean, bright sheet at the bottom of the Earth, an endless frozen field. But beneath your boots, not very far in the scale of this place, the picture changes completely. Under a thickness of ice that could rival a city of skyscrapers stacked on end, there is water. Not a lake, not a pond, but a vast black ocean pressed up against the underside of the ice. Make yourself comfortable as you can be while we peel back that surface in our minds. Now, picture what happens if we could look sideways into the ice shelf, as if it were made of glass. We would see a long, low cavity filled with seawater at or just below the freezing point, so close to solid that a tiny change in pressure or salt can tip it into ice again. There is no sunlight here at all, only darkness layered with more darkness, and above it, a ceiling of ice hundreds of meters thick, bearing down with the weight of years. Closer to the open ocean, that hidden water can move and swirl, carrying slightly warmer currents that gnaw at the ice from below, carving smooth channels and deep basins. Farther inland, where the shelf reaches back toward the continent, there is a quieter, stranger boundary. This is the grounding line, the place where the ice sheet finally lifts away from the bedrock and begins to float. On one side, ice is welded to the earth. On the other, it becomes part of the ocean's slow breathing. Those grounding lines are often not at the coast at all, but hundreds of kilometers inland, tucked into valleys and over-buried ridges we only know from radar echoes. Between the open sea and that invisible hinge stretches a labyrinth of dark rooms and corridors, channels as tall as high-rise buildings, sills and basins where cold, heavy water pools, and narrow throats where the tide squeezes through under unimaginable pressure. We're going to spend the rest of this journey trying to follow that maze, but for now it's enough to notice how little of it we've actually seen. We have better maps of the surfaces of Mars and the Moon than of the seafloor hidden under these shelves of ice. For all our satellites and sensors, much of this under-ice ocean is still guessed at, sketched from hints and shadows. And somewhere in that black water, clinging to ice walls or drifting in the slow current, there may be life that has never known the sun. To find out, we have to send our fragile machines into this silent, shifting world, and that is where the real difficulty begins. Why we haven't and can't easily go there. So when we talk about going there, to that black water beneath the shelves of ice, it's important to slow your thoughts for a moment and notice something subtle. This is not just another blank spot on the map, waiting patiently for us to arrive. This is a place that seems to lean away from us, that quietly undoes our efforts even as we make them. We often picture unexplored regions as deserts we have not crossed yet, or valleys we simply haven't walked into. If we had more time, more fuel, more courage, we imagine, we could just push a little farther. But under Antarctica's ice shelves, the problem is different. It is not only that we haven't gone, it is that the ice, the ocean, and the deep cold are constantly moving the doorway itself, so that any path we open begins to close almost as soon as it exists. Now, picture what happens when we try to make an entrance. We melt, or drill a narrow shaft through hundreds of meters of floating ice, hoping to reach the seawater beneath. Above us, the glacier is flowing outward toward the sea, creaking and stretching under its own immense weight. Around the hole, hidden fractures and crevasses shift, tides lift and lower the shelf by meters, and the whole structure flexes like a slow-breathing lung. A stable platform is rare. A crack in the wrong place can twist a drill, snap cables, or simply swallow the instruments we lower down. Even when the ice holds, the water can erase our work. The seawater under the shelf can be slightly warmer than the ice above, or just as often, supercooled and ready to freeze the moment it is disturbed. As our hot water drill retreats, the borehole walls begin to refreeze from all sides, narrowing like a closing pupil. Slushy crystals grow, thicken, and can lock a probe in place. It is as if the world beneath reaches up and seals the wound we made, leaving almost no trace that we were ever there. In that combination of cold, pressure, and isolation, our machines themselves begin to fail. Batteries lose strength far faster than they do at the surface. Electronics that work perfectly in a warm lab misbehave after hours in salt water, just below freezing. There is no GPS signal under the ice, only dead reckoning and careful acoustics, so a small error in direction, repeated over hours, can send a robot wandering in the dark with no easy way home. Make yourself comfortable with one more thought. The ice shelves do not rage against us. They simply move. They rise and fall with the tide. They stretch and crack and heal over years and decades. And in doing so, they shrug off our cables, bend our shafts, and gently push shut the doors we try to hold open. Follow me a little farther, and we're going to see how, despite all this, people still dream of sending more ambitious explorers into that hidden sea. To understand the ceiling, we must understand the river of ice. Follow me a little farther, and before we go back down into that hidden sea, we need to look more carefully at the ceiling itself. To understand why the world beneath the shelves is so hard to reach, we first have to understand what those shelves really are, and what they are doing, slowly, constantly, all the time. We often picture Antarctica's ice as something fixed, like a frozen lid pressed down on the edge of the Earth, solid and still. We imagine a white continent, a flat sheet, a cold weight that simply sits there for thousands of years. But that picture is quietly wrong. Under its own immense pressure, the ice is not resting, it is flowing. Now, picture what happens when snow falls, year after year, century after century, in the deep interior of the continent. Layer builds upon layer, the weight above squeezing the layers below until the ice deforms and begins to creep outward, seeking lower ground. That slow outward creep, pushed by gravity and thickness, is a river, even if it moves only meters each year. That's what a glacier is, not a frozen lake, not a block, but a very slow river of ice, spreading from the high interior toward the sea. As these rivers of ice reach the coast, some of them do not immediately break and float away as separate bergs. Instead, they slide off the rock and continue out over the ocean, still attached to the ice behind them, but now buoyed up by seawater hundreds of meters deep. These floating tongues widen and thin, sometimes stretching hundreds of kilometers from land. Those are the ice shelves, the Ross, the Filchner Rhone, the great pale platforms that look so calm from above. Because they are part of a flowing system, these shelves are never truly at rest. The ice is being pulled from behind and lifted from below, so it stretches, thins, and cracks, opening long fractures that can run for tens of kilometers, then healing them with winter snow, then opening them again. Over years, the surface we stand on is carried seaward like a very slow conveyor belt. until it eventually carves into the ocean and drifts away. This has a quiet but brutal consequence for exploration. Any tunnel we melt, any borehole we drill, any access route we carve down through hundreds of meters of ice is etched into something that is drifting, bending and slowly changing shape. The hole begins to refreeze, the walls deform, the upper opening moves relative to the lower one. A passage that was straight becomes crooked. A shaft that once touched a specific spot beneath the shelf can, over time, miss it entirely. So when we talk about a dark ocean hidden beneath a moving ceiling, we are talking about a world that is always shifting just out of reach. Make yourself comfortable for a moment and slow your thoughts and imagine trying to study a deep black lake while standing on a raft that is cracking and gliding away under your feet. That is the challenge scientists face here. And in the next part, we're going to see how they still try to send fragile machines into that restless space between ice and sea. Snowflakes to cathedrals of ice. To understand those fragile machines and the restless space they enter, we need to step far away from the cracking edge and walk in our minds into the stillness of Antarctica's interior. Here, nothing seems to move. The air is thin and dry, the cold is so deep it almost feels like a sound. And yet, grain by grain, something is quietly being built that will one day become those vast shelves at the coast. Imagine a single snowflake drifting down through that pale sky, turning slowly, settling on a surface that has already been buried and reborn countless times. Then another follows, and another still, not for minutes or hours, but for winters stacked on winters, for years, for centuries. Make yourself comfortable with that time scale for a moment. Now picture what happens when this gentle dusting of snow never truly melts, when each season simply lays a new sheet over the last, like pages in a book that no one ever stops writing. At first, the layers are soft, full of air, easy to crush in your hand if you could stand there and scoop them up. But as the stack thickens, as tens of meters become hundreds and then thousands, the pressure from above begins to work its slow, patient change. Snow becomes firn, a kind of halfway state, grains welding together while pockets of air are squeezed into smaller and smaller spaces, until, deep below the surface, that open, sparkling snow is transformed into dense blue glacial ice. Tiny bubbles are trapped there, sealed under the weight of everything above, holding whispers of ancient atmospheres, tiny samples of the Earth's breath from tens of thousands of years ago. We often picture ice as a flat sheet, thin and fragile, but the Antarctic ice sheet feeding those shelves is anything but thin. In places it rises nearly 3 kilometers from bedrock to surface. A vertical world of frozen water tall enough to stack 3 Eiffel Towers, one on top of the other, and still have room to spare. Thick enough to bury a city skyline so completely that only the tips of the tallest towers would brush the underside of the snow. It is not a crust, it is a continent of ice resting on a continent of rock. And under that immense height, the ice itself begins to behave in a way that feels almost alive. Not solid like glass, not loose like water, but something in between. A viscous, flowing body that slowly deforms under its own enormous weight. That's what a glacier is. Not a frozen statue, but a river of ice that, given enough years, will creep and stretch and bend around hidden mountains and deep valleys beneath it. We're going to follow that river now, very slowly. Each snowflake that once fell so gently in the interior is carried millimeter by millimeter, then centimeter by centimeter, outward toward the coast. It may take 10,000 years for a single particle of ice to make that journey, sliding over buried ridges, squeezing through narrow passes, accelerating down invisible slopes. The motion is too slow for our eyes, but if we could watch it in time-lapse, the whole ice sheet would look like a vast white ocean, flowing outward in all directions from the high, cold center. Here is the pattern interrupt. After all that crushing weight, all that downward force, the story ends not with more sinking, but with rising. Eventually, the creeping ice reaches a place where the rock beneath it drops away and the ocean pushes back. The pressure from below changes everything. The glacier, still attached to the land far inland, begins to float at its seaward edge, spreading out into a broad, flat platform, an ice shelf. All that ancient snow, all those buried bubbles of past air, are now suspended over black seawater, forming the roof of the hidden world we've been trying to reach. In the next part, we'll step out onto that floating edge and look down, through the ice, toward the deep, unseen ocean beneath. When ice starts to float, birth of an ice shelf. We're standing now on that broad, quiet platform of ice, but to understand what truly lies beneath it, we have to follow the journey that brought it here. Make yourself comfortable for a moment and slow your thoughts, because this journey does not rush. It takes hundreds, even thousands of years, and it begins far inland, where the cold is older than our memories. We often picture Antarctica's ice sheet as a frozen dome simply sitting in place, yet in reality, it is always sliding, always flowing, pulled downhill by its own immense weight. Deep beneath the surface, the bedrock is not flat at all, but carved into hidden mountain ranges, deep basins, and long valleys that slope toward the coast and then sink below sea level, creating low, secret gateways where the ocean can creep inland under the edge of the ice. Now, picture what happens as this river of ice moves toward those gateways. For a long distance, the glacier is still grounded, its weight pressing hard on rock, grinding sediments, squeezing out meltwater under enormous pressure. That's what a glacier is, not just frozen water, but a slow, heavy conveyor, dragging the high interior of the continent toward the sea. Step by step, meter by meter, it approaches a line it cannot see, but that will change everything. That invisible boundary is called the grounding line, and it is one of the most important places in this entire frozen world. On one side, the ice is held up by solid earth. On the other, its weight is supported by seawater. At the grounding line, the glacier finally becomes light enough to float, and in that moment it changes from a land-bound ice sheet into the beginning of an ice shelf, still attached, yet already part of the ocean. From there, we're going to follow the ice outward, as it spreads over the sea like a thick, rigid skin. In places like the Ross and Filchner-Rhone shelves, this floating extension stretches for hundreds of kilometers, a flat, pale plain that seems motionless from above, but is slowly flowing, bending and flexing as tides rise and fall in the darkness below. Beneath this floating roof lies a wedge of seawater, the subice shelf cavity, narrowing where it reaches back under the grounded ice, widening where it opens to the deep ocean. Its ceiling is sculpted ice. Its floor is a seafloor we have barely mapped, with ridges that steer the water, and deep troughs that invite it farther inland than we once thought possible. Into this hidden space, warm circumpolar deep water can sometimes find a path, slipping along submarine valleys, rising just enough to lick at the ice from below. A small change in the shape of that valley, a slightly deeper sill, a gentler slope of bedrock beneath the grounding line, and the whole behavior of the cavity can shift. More melting here, less there, channels opening, pillars thinning, the shelf above quietly weakened. Because somewhere ahead of us, in that dark wedge of ocean under the ice, the exact way that water moves will decide which parts of Antarctica stay frozen in place, and which begin to let go. And in the next section, we'll step over that grounding line in our minds and follow the first faint currents as they slip into the deep cold beneath the shelf. The giant corks holding back a continent of ice. Those first faint currents slip under the ice like someone quietly opening a door, and once they are inside, they meet some of the largest floating structures on Earth. Make yourself comfortable for a moment, and imagine the far edge of Antarctica not as a clean white line, but as a ragged fringe of vast, drifting platforms of ice, each one a kind of gate between the continent and the sea. We often picture Antarctica as a single solid block. But around much of its coast, the ice is already afloat, spreading out over the ocean as shelves hundreds of meters thick. The Ross Ice Shelf, big enough to swallow countries, hangs from the edge of the continent like a frozen balcony. On the opposite side, the Filchner-Rhone Ice Shelf stretches over a deep, cold basin. To the west, in a region that worries scientists, the shelves fringing Thwaites Glacier lean out over dark water, while farther north, the Larsen shelves cling to the Antarctic peninsula, some of them already broken and gone. These are not just passive rafts. They are giant barriers, pressed gently but firmly against islands, peninsulas, and underwater ridges, feeling the slow pressure of the glaciers that feed them from behind. That's what a glacier is, after all. Ice that has flowed for years under its own weight, creeping seaward until it begins to float. Where the shelf touches rock at the sides, or scrapes over shallow rises on the seafloor, it acts like a brace, a hand on the shoulder of the ice upstream, holding it back just enough to keep its motion calm. Now, picture what happens if you remove that hand. A simple way to see it is to imagine a bottle, not filled with water, but packed with deep, ancient ice. At the neck of the bottle sits a cork, and that cork is the ice shelf. As long as it is there, the ice inside can only ease outward slowly. Take the cork away, and the contents can surge, not all at once, but faster and faster still. Around Thwaites, where the inland bedrock slopes downward beneath the ice, that change in speed could send more and more frozen mass into the ocean, raising sea level far from this lonely place. The quiet danger is that these corks can weaken from below long before the surface reveals anything is wrong. Warm, salty water, guided by the shape of the hidden seafloor, can slip deep beneath the shelves, melting them from the underside, carving channels and thinning them invisibly. From above, the ice may still look solid, flat, eternal. Beneath, the supports that give it strength may already be fading. How can we predict the future of our coasts if we do not know how quickly those unseen beams are being cut away? So when we talk about the world beneath Antarctica's ice shelves, we are not indulging in a distant curiosity. We're going to follow these under-ice oceans because they are the quiet machinery that will decide which shelves keep their grip and which corks fail. In the next part, follow me as we sink our attention down into that black water itself and watch how a slight change in its warmth, its path, or its depth can reshape the outline of continents over the coming years. Warm water in a frozen realm. So, let's do what we promised and sink all the way down into that black water. Make yourself comfortable for a moment and let your attention drift from the bright frozen surface to the slow shadowed currents turning far beneath our feet, in a place where no light and almost no sound ever truly arrives. Down there, circling the entire continent, is a kind of deep, unseen river. Scientists call it circumpolar deep water, but we can think of it as a band of relatively warm, salty ocean wrapped like a dark belt around Antarctica, flowing hundreds of meters below the surface, patient and persistent, carrying heat that has been wandering the world's seas for years before it reaches this cold edge of the Earth. We often picture Antarctic waters as uniformly frigid, locked at the freezing point, simple and still. Not because we are careless, but because the ice above feels so absolute. Yet this deep current is a quiet contradiction, only a few degrees above freezing, but warm enough and dense enough to matter. Under the right conditions, that extra warmth becomes a key that can unlock the underside of the ice shelves themselves. Now picture what happens when the winds above the Southern Ocean shift, even slightly. Stronger westerly winds can push the surface waters aside, and like a slow-motion upwelling breath, the deep circumpolar water is drawn upward onto the continental shelf, climbing the submerged slopes and ridges that lie hidden beneath the ice edge, guided by valleys and troughs carved into the sea floor over millions of years. As it rises, this water finds openings, Submarine canyons, low passes in the underwater landscape, gaps at the front of the ice shelves where the floating ice lifts just enough to leave a dark doorway. Through these thresholds, the warmer water slips into the sub-ice shelf cavities, entering a world of overhanging ice ceilings, enormous pressure, and total night. It does not rush. It creeps. Imagine long, invisible fingers of slightly warmer water stretching inward, hundreds of kilometers under the ice, feeling their way along the base of the shelves. Wherever they touch, they begin to melt the ice from below, not in dramatic crashes, but in slow, persistent thinning, carving sinuous channels, under ice caves, and broad, flat terraces into the hidden underside of the glacier roof. In West Antarctica, this process is not just a curiosity, it is a major driver of accelerated ice loss. Around Thwaites Glacier, sometimes called the Doomsday Glacier in news headlines, these incursions of circumpolar deep water are eating away at the very points where the ice still clings to the seabed, loosening the cork that holds back vast inland ice and quietly rewriting future sea levels. But all of this, the warm fingers, the melt channels, the collapsing under ice staircases, happens out of sight. To truly see the patterns they carve, to map each hidden groove and tunnel, we would have to send delicate instruments into a realm no sunlight has ever reached. And in the next part, follow me as we watch what it takes to risk that journey into the dark. A river network in the dark. Down there in the dark, the journey doesn't end with a single warm finger of water touching the ice. It widens. It branches. It becomes a whole secret landscape. We often picture the underside of an ice shelf as a simple, smooth ceiling over the ocean, a flat white lid sealing off the cold water below. But it isn't flat at all. Make yourself comfortable for a moment and imagine turning that world upside down. The floor above the ocean is made of ice, and over years, under steady pressure and flowing water, it has been carved into ridges, channels, and broad-stepped terraces. Some grooves are only a few meters deep, others are like submerged canyons tens of meters high, running for many kilometers beneath the shelf, guiding water the way river valleys guide air at the surface. Now, picture what happens far inland, where the ice is still grounded on rock. At the base of the glacier, friction and pressure melt a thin film of water, which gathers in pockets and streams and slowly begins to flow downhill, pulled toward the distant ocean. That melt water can travel through hidden valleys and tunnels, then slip under the floating ice shelf and join the seawater there, adding its fresh cold pulse to an already complex network. Where this fresher water meets the salty ocean beneath the shelf, something subtle happens. The mixture is slightly lighter than the deep sea, yet still very cold, so it rises along the underside of the ice as a buoyant plume, hugging the ice base, weaving through the existing channels. As it rises, it can melt the ceiling above it, enlarging some passages, while in nearby hollows, supercooled water encourages new ice crystals to grow and refreeze, thickening the shelf from below. Not just melting, but melting and freezing side by side. Over time, these plumes sculpt the underside into a kind of inverted river delta, with branching paths and quiet backwaters. That's what a glacier is when it meets the ocean here. Not a solid block, but a moving, breathing interface where water and ice constantly trade places. In some spots, radar has revealed giant basal cavities, hidden rooms in the ice hundreds of meters tall, where water can swirl in loops for years before escaping. Because we can't see this directly, we read it like a shadow play. Tiny changes in satellite height measurements hint at where the ice is thinning from below. Airborne radar traces the roughness of the hidden ceiling. Together, they reveal sub-ice rivers that can stretch for hundreds of kilometers, feeding melt channels that steer warm water toward vulnerable grounding lines. So beneath Antarctica's shelves, we're going to find not a still, silent void, but a restless plumbing system, rearranging itself moment by moment. It is unseen, but not inactive. And in the next part, follow me as we ask what happens when this hidden circulation shifts and the whole floating edge of the ice sheet begins to respond. Life without light. Who lives under the shelves? So beneath Antarctica's shelves, we're going to find not only a restless plumbing system of water, but something stranger still moving within that water. Not just currents, but life. In a place where, at first glance, life should not be able to endure at all. Now, picture what happens when you leave the bright white surface and slip in your mind down through hundreds of meters of ice. The glow of the world above vanishes. The last scattered blue light is swallowed, and you arrive in a cavern of black water pressed between rock and ice. A cold, flooded ceiling stretching for hundreds of kilometers. The temperature hovers just below freezing. The pressure is many times what you feel at sea level, and food, in any ordinary sense, is almost absent. We often picture oceans as sunlit shallows full of fish and color, but here there is no sunrise, no moonlight, no seasons of light and dark, only a permanent polar night. The water creeps slowly along the underside of the glacier, thin melt channels guiding it, while tiny particles drift down like sparse snow from the distant open ocean. For years at a time, nothing large may pass by. It feels, even in our imagination, like an empty, sealed world. And yet, it is not empty. When scientists have managed to drill narrow windows through the ice and lower cameras into this hidden place, they have found the quiet opposite of lifelessness. Microbial mats, thin films of bacteria and other microbes, coat rocks and sediments like dark, living carpets. Strange, pale filter feeders and other small animals cling to boulders, to the underside of the ice, to any stable surface they can find, holding their position in the slow, deep flow. In 2201, on the Filchner-Ronne ice shelf, a team drilled through about 900 meters of ice and expected to see bare seafloor. Instead, their camera revealed a single boulder far from open water or sunlight, with stationary animals fixed to it, like tiny anemones or sponges frozen in mid-bloom. Total darkness. No obvious source of food, no direct path to the surface. It was as if a small cliff from some distant continental shelf had been hidden away under the ice and quietly populated over thousands of years. How did they survive here, in this cold, pressurized, almost foodless place? One answer is patience. Particles of dead plankton and other organic material can drift in from the open Southern Ocean, carried under the shelves by deep currents, and these animals may simply wait, filtering out whatever passes by. Another answer may lie in the rocks and sediments themselves, where microbes can draw chemical energy from minerals and dissolved gases, building a whole food web without any sunlight at all. So as you make yourself comfortable and slow your thoughts, follow me to a gentle but unsettling idea. The space beneath Antarctica's ice shelves may be peppered with communities like this, scattered oases we have never seen, linked by currents we barely understand. In that sense, the hidden oceans under the ice are as biologically mysterious as deep space, a dark frontier on our own Earth that we have only just begun to glimpse. And that will shape the questions we ask in the next part of our journey. Pressure, silence, and deep time. So now, with those scattered oases glowing in our minds, make yourself comfortable again and follow me a little deeper into this hidden world. Not to another strange creature this time, but to the quiet that surrounds them, the slow, patient forces that have been shaping this place for far longer than we have been watching. Imagine you are suspended under an Antarctic ice shelf, in the black water between rock and ice. Above you, hundreds of meters of frozen ceiling press down, a floating lid as thick as a skyscraper is tall, and below you, hundreds more meters of cold, heavy ocean descend into darkness. All of it is under pressure, squeezed from every side, so evenly and so completely that almost nothing seems to move at all. We often picture the ocean as restless, full of waves and storms and foam. But down here, the surface is far away, and the chaos is filtered out. The water creeps instead of sloshing, guided by tiny differences in salt and temperature, by the faint pull of tides, by the slow breathing of the ice above. It feels less like weather and more like the steady circulation of a deep, old lung. Now, picture what happens to sound in a place like this. There is no wind, there are no breaking waves. Mostly, there is a soft, almost velvety silence. And then, from far off, a low creak as the ice shelf flexes with the tide, a drawn-out groan that might last for minutes. Somewhere else, the muffled thud of a distant carving event, where a piece of the shelf has broken free into the open sea, arrives as a dull, delayed rumble. Closer by, there are smaller noises, so gentle we would miss them at first. The faint hiss of tiny ice crystals forming where supercooled seawater touches the shelf, and then melting again as warmer deep water slides past. The occasional patter of fragile ice, like a slow-motion snowfall rising instead of falling, grains of frozen seawater drifting upward to weld themselves to the under-ice roof. All of this plays out on timescales that ask us to slow our thoughts. A single loop of water under some shelves may take decades, even centuries, before it escapes back to the wider ocean. The ice overhead has taken thousands of years to flow from the interior of the continent to the coast, carrying with it traces of ancient snowfalls, old volcanic ash, tiny bubbles of past atmospheres. And then there is us. Our expeditions last a few weeks, maybe a season if we are lucky. A hot water drill might stay open for only days before the borehole begins to refreeze, gently pushing our cables and instruments back toward the surface. We arrive with bright lights and careful plans, and the ice simply waits and closes and returns to its own rhythm. It is a strange feeling to realize that we are not the main characters here, but brief visitors to a conversation between ice and ocean that has been going on since long before our species existed. Instead of urgency, there is a kind of calm in that realization, a humility that comes from knowing the world beneath the glacier will continue its slow work whether we are watching or not. And yet, this is not a static peace. As warmer deep water reaches farther under the shelves, that ancient dialogue is changing, and in the next part of our journey, we're going to listen more closely to how those changes echo far beyond this frozen place. Lake Vostok and the clues beneath the continent, so as that distant conversation between warm deep water and creaking shelf ice continues, we're going to leave the coast behind for a moment and sink our attention farther inland, into a part of Antarctica that feels even more removed from our everyday world. Make yourself comfortable and slow your thoughts, because where we're heading now has never seen the sky. We often picture Antarctica as a single solid block of frozen land, a simple white shield resting calmly on rock. But beneath the grounded ice sheet, far from the open ocean and the flexing shelves, there are lakes, whole chains of them. Imagine standing on a flat, featureless surface of ice, the air razor cold and still, and knowing that nearly 4 kilometers straight down, under crushing pressure, there is liquid water pooled in the dark. The most famous of these is Lake Vostok, a hidden basin roughly the size of Lake Ontario, stretching for more than 200 kilometers, with depths that reach close to 1,000 meters in places. It has probably existed in some form for at least 15 million years, sealed away from the atmosphere by a continuous roof of ice, its waters stirred not by wind, but by the slow melt and refreeze at its ceiling and floor. Now, picture what happens to a body of water that old, that isolated, that deep. Sediments build up in quiet layers, chemical gradients form, and any life that survives must adapt to a world without sunlight. We did not find Lake Vostok by accident with a drill. Long before anyone touched it directly, aircraft and tractors crawled over the surface, towing radar that could see through the ice, and seismic waves were sent down to echo from the bed. Those signals returned a smooth, flat reflector where rough rock should have been, hinting at open water, then at its shape, then at its true scale. For years, the lake was more a pattern in the data than a place we could visit. Lake Vostok became a kind of mirror for our imagination. If such a vast, ancient, and complex system can exist entirely beneath grounded ice, with channels, basins, and perhaps even currents, then the hidden oceans under the floating shelves may be just as intricate, stitched together by narrow passages and perched cavities we have barely begun to map. The difference is that under the shelves, those waters are not completely sealed. They breathe, slowly, with the sea. And even with all the attention Vostok has received, our touch has been hesitant. Drills have approached it over decades, using special fluids and careful sterilization, stopping just short, then taking only limited samples of refrozen lake water that rose into the borehole, rather than plunging instruments freely into the open basin. Not because we lack curiosity, but because we fear contaminating a cold, untouched world before we even understand it. If reaching one lake beneath stable ice is that difficult, what does it mean to send machines into moving cavities under a restless shelf, where the ceiling itself is flowing toward the sea? In the next part of our journey, we'll follow one such attempt and see how close we've actually come to swimming in that black water beneath the ice, from hidden lakes to hidden seas. So now, follow me from that single sealed lake into something wider and stranger. We're going to stay beneath the ice, but we're going to trade a closed room for a vast, dark hallway that runs all the way out to the sea. Lake Vostok and lakes like it are pockets of freshwater locked in by ice on every side, cut off from the air and the light for millions of years, shaped by slow melt from the glacier above and by the pressure of the ice pressing down. They are almost completely self-contained, their chemistry, their sediments, and very likely their tiny ecosystems evolving in isolation, like messages written and then sealed away deep inside the cold body of the continent. Now, picture what happens when the ice no longer sits on rock, but begins to float. The solid base falls away, the bottom of the glacier lifts, and between the ice and the seafloor there opens not a lake, but an ocean roofed in white. These are the sub-ice shelf seas, where the water is salty, where tides still move, and where, at least in principle, a drop of water beneath your feet could one day drift out into the wider world ocean. We often picture the ocean as open sky above waves, but here the ceiling is hundreds of meters of ice, sometimes close to a kilometer thick, and the only light is the faintest blue glow filtering a short distance down before fading into black. It is still a hidden place, almost certainly with its own complex circulation, where cold, supercooled water flows inward along the seafloor and slightly warmer deep water creeps back under the shelf to gnaw at its base. Sediments rain down from the ice and wash in from the land, forming soft layers that may record years, centuries, even whole ice ages. Unlike Lake Vostok, these undershelf oceans are not fully sealed, yet they are still profoundly cut off from wind, storms, and seasons at the surface. They feel the pull of the moon as tides flex the ice roof. They feel the slow breathing of global currents. But no direct sunlight ever reaches their floors. It is very likely that many of them host life. Microbial mats on rocks, tiny animals filtering what little food the currents bring, patient communities adapted to cold, to darkness, to stillness. For a brief moment, we were allowed to peek. When the Larsen B ice shelf in the Antarctic peninsula collapsed in 2002, a solid platform that had been in place for thousands of years shattered and drifted away, and the ocean that had been hidden beneath it was suddenly open to the sky. In the years that followed, when ships and cameras finally reached that newly exposed seafloor, they found sponges, filter feeders, and delicate organisms that had been living in dim, filtered light under the ice, surviving on a thin rain of nutrients from above. Their world had changed almost overnight. That accidental unveiling is a reminder and a warning. Most other shelves are still intact, their undersides almost entirely unseen, Their grounding lines far inland where we have only a handful of drill holes and a few brave robots. It is almost certain that each one shelters its own version of a hidden seascape, carved by local valleys and ridges in the rock, stirred by particular patterns of current and tide, written by its individual history of advance and retreat. Make yourself comfortable with that thought for a moment. Under every broad, white shelf we see from space, there is a different unknown coast in the dark, waiting silently beneath our feet. Seeing through ice, our ghostly maps, each of those unknown coasts in the dark has, over the years, begun to acquire a faint outline in our minds, as if someone were sketching the edge of a continent with the softest of pencils. We often picture scientists disappearing into the cold with drills and robots, but much of what we know about this hidden world beneath the ice shelves comes from tools that never touch the ice at all. Follow me, just in your imagination, to a small aircraft humming slowly over the white surface. Inside, there is an instrument that sends gentle pulses of radio energy down through the ice, waiting for echoes to return. This is ice-penetrating radar, not a harsh beam, but a kind of careful listening, where each reflection from the bedrock or from the place where the glacier starts to float on the ocean tells us how thick the ice is and how the buried landscape rises and falls. Now, picture what happens when we repeat that flight again and again, year after year, and then add satellites circling high above the Earth, watching patiently. Some of them measure tiny changes in the height of the ice surface, sometimes just a few centimeters, as shelves thin, sag, or gently lift. Others sense delicate variations in gravity, which shift when there is dense rock, or lighter ice, or a deep cavity of seawater hidden below. From these subtle changes in height and pull, we can infer where channels snake under the shelves, where great voids open, where the grounding line may be retreating inland. What emerges is not a photograph, but something more ghostly, a set of outlines and shadows that show us where the ice is thick and where it is thin, where it clings to the bed and where it floats free, how that balance is moving with time and temperature and pressure. We're going to use these ghost maps to say, with some confidence, that warm circumpolar deep water is reaching far under West Antarctica, or that a buried mountain range is steering the flow of a glacier, even though no human eye has seen those places directly. But there is a quiet honesty we have to keep. These methods give us shapes and motions, not textures and faces. Radar cannot tell us what kind of microbial mat clings to a rock, or how a fragile filter feeder sways in the black water under hundreds of meters of ice. Gravity cannot show us the color of sediments, or the exact temperature at a crack in the shelf where meltwater rises and refreezes. So we sit with these beautiful, incomplete maps, and we slow our thoughts, knowing that to truly understand this deep, cold world, we would have to go there in person, to send instruments down through the ice itself. And that is where the real difficulty begins, because the moment we try to turn ghostly outlines into direct contact, the ice starts to push back, measuring from above versus touching the unknown. So we sit with these beautiful, incomplete maps, and we slow our thoughts, that there is a point where lines on a screen are no longer enough, where the ghostly colors of satellite images begin to feel strangely flat. We can see where the ice shelves are thinning, where the Ross or the Filch Neron seem to sag at the edges, where Thwaites shows a widening wound, and yet we still have not actually been there, beneath in the black water that is doing the carving. Remote sensing is powerful, almost magical in its own quiet way. From aircraft and orbit, we measure tiny changes in height, faint variations in gravity, delicate shifts in the ice's microwave glow, and from that, we infer where warm circumpolar deep water is slipping inland under the shelves, where the grounding line has retreated, where melt channels snake unseen for hundreds of kilometers. But notice what is missing. We do not see the ice itself up close, its fractured ceilings and smooth undercut ledges, the exact places where water brushes, swirls and pulls it away. We often picture exploration as a person in a bright suit, standing in a cave, breathing in the cold air, and running a hand along the wall. That impulse does not vanish just because the cave is flooded and roofed by hundreds of meters of ice. We still want to see, to touch, to film, to know not only that a cavity exists, but what it feels like to float in that hidden, pressurized world, listening to the creak of a ceiling the size of a continent. Maps and models tell us where to look. They do not tell us what it is like to be there. To even try, we have to send our senses down without us. Follow me for a moment through that journey. A narrow borehole is melted through the shelf, racing the refreezing ice, and for a brief window we lower instruments into the deep. They measure temperature, salinity, and currents, tasting how fresh meltwater layers over salty seawater, how fast the flow is stripping ice from the grounding line. Cameras look outward, and if we are lucky, show us a pale wall, a drifting cloud of sediment, perhaps a cluster of strange filter feeders clinging to rock in perpetual night. But these glimpses are short-lived. The hole begins to close, batteries drain, cables snag. Most of our probes can travel only a few kilometers from their entry point. Then they must turn back or be lost. Now, picture what happens if we dream bigger. We're going to imagine long-range robots wandering for months under the Ross Ice Shelf, mapping every channel, every rise in pressure, every form of life. That is the future we reach for. Yet for now, navigation without GPS, the crushing weight of ice above, and the sheer distances involved keep that dream mostly on paper. And so we stand on the roof of this world, able to sketch its rooms by remote touch, able to lower a camera into the dark for a few quiet hours, but not yet able to walk its corridors. Make yourself comfortable with that thought for a moment, because this gap between seeing from above and touching the unknown below is not just a technical inconvenience. It is the heart of the mystery. And in the next part, we'll step closer to the fragile machines that dare to cross it, drilling a hole into the abyss. So now, follow me from that distant, remote touch down to the very roof of that hidden ocean itself, where the ice is not just something we look at from space, but something we must physically pierce. We often picture Antarctica as a single, solid block of frozen land. But here, along its edges, the ice shelves spread out like vast floating terraces, hundreds of meters thick, drifting over a dark sea we almost never see. To reach those shelves at all, we first have to cross a world of ice. Ships push through pack ice and drifting floes until the sea hardens into a continuous pale surface, and then the work moves to aircraft and over-ice traverses. Slow caravans of sleds and tracked vehicles carrying fuel, hoses, and delicate instruments across a cold, white plain. After days or sometimes weeks, a small cluster of tents and containers appears on the horizon, a temporary field camp pinned to the surface by snow anchors, and habit surrounded by nothing but wind and the faint creak of the glacier beneath. Here, in this lonely place, we're going to drill a hole into the abyss, not with a spinning metal bit, but with hot water. Engineers melt snow, heat it, and pump it back down through insulated hoses, carving a narrow shaft, perhaps no wider than a person, through hundreds, sometimes nearly 1,000 meters of ice. Now, picture what happens. The water falls, melts, swirls, and the ice around the boreholes softens and flows, while above, generators hum steadily, holding back the cold with borrowed fire. But the ice is patient, and it does not wait for us. As soon as the drill passes, the borehole begins to refreeze, its walls thickening inward under pressure, trying to heal the wound we have opened. There is a brief window, sometimes only hours, when the shaft remains open enough to lower instruments, cables, and cameras down into the deep. Every delay, every stuck connector or frozen glove eats away at that time. The hole is literally closing around our curiosity, and we cannot simply rush. Somewhere beneath, there may be fragile ecosystems that have been sealed off for thousands or even millions of years, entire communities of microbes or small animals that have never known the modern surface world. To protect them, every drop of drilling water must be filtered and sterilized, every hose scrubbed, every instrument cleaned so it carries no hitchhiking cells from our own world. That level of care slows everything, turns each movement into a deliberate, almost ceremonial act. So we stand on this thin camp above an unseen ocean, racing a refreezing shaft while trying not to disturb what lies below. And even when, finally, the drill breaks through and the cable finds water instead of ice, the real difficulty is only beginning, because what waits beneath the shelf is not a calm swimming pool, but a dark, shifting space that can twist and swallow our machines in ways we're only starting to understand. Robots under the ice, Icefin and friends. So when that narrow column of water finally opens beneath the ice shelf, we don't climb down ourselves. We lower our stand-ins, little mechanical explorers built to go where our lungs and our nerves would fail. Make yourself comfortable for a moment and follow me into that darkness with one of them. We often picture a submarine as a bulky steel cylinder, bristling with equipment, but the robots we send under Antarctic shelves are slender and almost fragile, designed to slip through a drill hole barely wider than a person's shoulders. Icefin, Autosub, and their cousins are long, torpedo-shaped vehicles, lowered on a cable or gently released, then left to swim on their own in a world with no light, no ceiling we can see, and no easy way home. Along their hulls are the sensors we wish we had down there. Cameras that drink in the faint glow of their own lamps and turn rough ice into ghostly images. Sonar that sends out pings and listens for echoes, slowly sketching the underside of the shelf in 3 dimensions. Instruments that taste the water, measuring temperature, salinity, and the subtle changes that tell us where warm, deep currents are licking at the base of the glacier. Under pressures that would crush a human diver, they move calmly, building maps we could never draw from the surface. Now, picture what happens when Icefin reaches Thwaites Glacier, sometimes called the Doomsday Glacier because of how much sea level it could add if it retreats. For years, models imagined a relatively smooth, gently sloping underside, a simple plain of ice melting quietly into the ocean. Instead, Icefin's cameras and sonar revealed a cold, chaotic place. Jagged ridges, steep steps, and sinuous melt channels where warmer water has carved pathways deep into the ice, like rivers turned upside down. Not a flat ceiling, but a rough, sculpted landscape that changes how we think this part of the Earth is losing mass. There is a quiet catch, though, and it shapes everything these robots do. Under hundreds of meters of ice, there is no GPS, no satellite whispering coordinates through the roof. Radio waves die quickly in seawater, and signals struggle to pass through thick ice, so communication is slow, limited, sometimes reduced to simple acoustic pings. The robot must know how far it has gone, how to turn, how to trace its way back through the black water to the exact drill hole, because if it misses by even a few meters, it cannot simply pop up somewhere else. In a way, each mission is like sending a small, thoughtful spacecraft into an alien ocean and asking it to return through a closing door. That's the pattern interrupt in our minds. This is not an endless open sea, but a roofed, shifting cavern that can trap a vehicle with a single collapse, or an unexpected current. We're going to rely on dead reckoning, on careful navigation software, on sparse beacons placed on the ice, and still, uncertainty remains. And despite all this sophistication, the scale is humbling. Icefin and its friends have traced paths of only tens of kilometers, thin lines of knowledge under shelves and glaciers that together span millions of square kilometers. We have exquisite detail along a few threads, and almost nothing in the vast spaces between. It's not that the robots are failing us, but that the world beneath the ice is simply too large, too deep, and too hidden for them to cover. So we stand on the surface, watching a cable disappear into a refreezing hole, holding detailed maps of a few corridors, while knowing that, just beyond those tracks, the under-ice ocean remains almost entirely unknown. In the next part, we'll turn to the tools we haven't yet fully built, cryobots and probes meant to melt their own paths downward, and ask what it would take to explore this realm more completely and what we might risk by trying. When the ice itself fights back. But even if we perfect those future cryobots, even if we design the most careful probes we can imagine, there is another problem waiting for us under Antarctica's ice shelves. The ice itself does not simply sit there and allow us to pass. It moves, it flexes, it pushes back. We often picture an ice shelf as a solid frozen roof, a clean white ceiling over a dark ocean, but that calm image hides a slow, persistent restlessness. The ice is flowing seaward under its own weight. The tides are lifting and lowering the floating slab, and far inland, at the grounding line where the glacier first begins to float, the whole structure is creeping like a very slow, very heavy jelly. That's what a glacier is, not a block, but a river of ice. Now, picture what happens when we lower delicate instruments into this shifting world. A borehole that is straight when we drill it can begin to bend as the ice around it deforms, its walls squeezing inward as they refreeze and flow. Cables that once hung freely can be pinched, dragged sideways, or slowly sheared between two slabs that are sliding past each other by a few centimeters a year. Under that much pressure, a few centimeters is more than enough. Follow me to the underside of the shelf where the ice meets the sea. Here, the tides rock the ice up and down, opening and closing tiny gaps, changing the geometry of the hidden cavity faster than our designs can adapt. A robot sent into a broad tunnel may find the roof sagging months later, or a narrow passage pinched nearly shut. The map we drew on the way in can be wrong on the way out. Sometimes, exits simply vanish. In the coldest corners, the water itself starts to build new obstacles. When seawater becomes slightly supercooled as it brushes the ice, tiny star-like crystals known as frazzle ice begin to grow in the dark, drifting like underwater snow. They seem harmless, almost beautiful, but they can collect on propellers, clog water intakes, and coat cameras and sensors in a cloudy film until the world beneath turns to fog. An instrument that worked perfectly in the lab can be blinded in hours. All the while, the environment is quietly wearing down the machines we send. The great weight of ice above means hundreds of atmospheres of pressure. The deep cold slows chemical reactions in batteries, shortens their lifetimes, and makes metals and seals more brittle. Joints stiffen, housings crack, and electronics that would run for years at the surface may fail after a single season down here. Every mission becomes a careful gamble with equipment that took years to build and may never come back. So the ice and ocean do something almost like a slow, deliberate dance around us, rearranging themselves, closing doors just after we pry them open, smoothing over the tiny wounds our drills make in their surface. We make ourselves comfortable, we slow our thoughts, we plan, and the environment quietly edits our plans away. And in the next part, when we finally send a cryobot down into this restless space, we'll discover that the real challenge is not just reaching the hidden ocean at all, but keeping a fragile thread of connection before the ice decides to sever it. One of Earth's hardest engineering problems. So when that fragile thread of connection finally reaches the hidden ocean, the story doesn't suddenly become simple. In some ways, this is where one of Earth's hardest engineering problems truly begins. We often picture exploration as planting a flag or landing a rover, a clear moment of arrival. But beneath Antarctica's ice shelves, there is no solid ground like that at all. Only a dark, shifting world under cold, floating ice. Make yourself comfortable for a moment and imagine a comparison we don't usually make. Landing a rover on Mars sounds impossibly hard. Months of travel through space, a plunge through a thin atmosphere, a few terrifying minutes when signals take too long to correct anything in real time. Yet sending a probe under an ice shelf shares that same lonely silence. that same delay, that same sense that once the sequence starts, we can only watch, not because space and ice are identical, but because both cut us off. Now picture what happens after the cryobot melts its way through hundreds of meters of ice and releases a small vehicle into that black water. Radio waves that talk so easily to Mars can barely whisper through solid ice, and seawater swallows them almost completely, so the robot cannot wait for us to tell it what to do next. It has to be fully autonomous, a quiet, thinking machine, making choices in the dark without our hands on the controls. If a tunnel collapses, if a current changes, if a ceiling of ice suddenly dips, it must decide in seconds whether to press on or retreat. To do that, it needs a way to know where it is, in a place with no GPS, no stars, no clear horizon. It sends out sound, listening for echoes from the ice roof, the seafloor, the steep walls of hidden channels, slowly building a three-dimensional map as it swims. The terrain is not a flat seabed, but a maze of overhangs and arches, grounding lines and cavities, places where pressure and meltwater carve deep pockets that could trap a careless vehicle forever. Getting lost here is not like taking a wrong turn on a road. It is more like drifting into a cave and having the entrance quietly close behind you. So engineers live inside trade-offs. A larger robot can carry bigger batteries and more instruments, but it moves clumsily through narrow melt channels. A smaller one can slip through tight spaces, yet runs out of power sooner, forcing a choice between mapping the way home and sampling the most alluring distant corner of the under-ice world. We're going to constantly balance safety against ambition, knowing that every extra sensor, every extra meter traveled, increases both the scientific reward and the risk of losing the vehicle entirely. Because in the end, these hidden oceans may be more technically demanding than many deep space missions we dream about. Not out there, above the atmosphere, but here on Earth beneath our feet, under ice that is alive and moving. And in the next part, as we follow one of these small explorers into that deep, cold place, we'll see how even the best designs must still bargain with the glacier itself. Returning to the alien ocean beneath our feet, so let's come back to where we are for a moment. Not out in deep space, but standing in our minds on that moving roof of ice, with a dark, cold world hidden just beneath our feet, and a small, humming robot bargaining with the glacier itself. Make yourself comfortable again, and let your attention settle on this simple, slightly unsettling thought. We are floating. Under Antarctica, these shelves are not solid foundations, but vast rafts of ice, hundreds of meters to more than a kilometer thick, drifting on black seawater that can reach hundreds of kilometers inland. We often picture a flat, empty underside, like the smooth hull of a ship, but now, picture what happens when warm currents of circumpolar deep water creep in, pressing upward, carving tunnels and caves and great vaulted chambers into the ice from below. The ocean shapes the ice, and the ice shapes the ocean in a slow, continuous conversation. Beneath that floating lid, the seafloor is not blank either. Radar pulses sent through the ice have revealed mountain ranges, buried valleys, and deep basins, a drowned landscape that once stood in the air and is now entombed in darkness. In places like the Ross or Filch-Narone shelves, the grounding line, where ice stops resting on rock and begins to float, lies far inland, hidden under this roof of ice and water and pressure. We're going to keep that image in mind, a continent-sized cavern, rock at the bottom, ice at the top, and a restless sea between. And in that sea, life. Not green, sunlit forests of algae, but thin microbial mats clinging to rocks, filter feeders fixed to the underside of the ice, strange communities that survive on chemical energy rather than light. Enduring years and years of unbroken night, we have seen only hints of them, brief camera glimpses through narrow drill holes that soon begin to refreeze, like a wound closing. For all our technology, all our ambition, and all our restless desire to explore, we still cannot simply roam there. This is the central tension of this world. From above, we can map the ice surface, track fractures, watch shelves like Larsen or Thwaites thin and retreat. We can send sound waves down and let them echo back stories of hidden channels and deep cavities. We can lower a robot once, maybe twice. But we cannot yet glide freely under the ice, turning at will, lingering where we choose. Not because we don't want to, but because the ice, the darkness, and the distance quietly push back. So, follow me inward for a moment, away from the machinery, toward your own body. Notice your shoulders. Are they tight? Let them loosen. Notice your breathing. Let it slow your thoughts, just a little, as if you were standing on that frozen surface, feeling the deep, muffled quiet of the world beneath. Because this is our alien ocean, without leaving Earth at all. A black sea under a frozen sky, where our robots are like the first landers on a hostile planet, touching down briefly, sending home a few images, then falling silent. Imagine being there, in that small machine, hearing only the creak of ice above and the soft hiss of water around you. Would you feel like an explorer on Earth or somewhere else entirely? In the next part of our journey, we'll trade this wide, abstract view for specific places, shelves that have already collapsed, shelves that are thinning fast, and shelves that still seem stable but hide unsettling changes at their grounding lines. We'll watch how warm water gnaws at their undersides, how entire frontiers of ice can vanish in a season, and we'll ask what that means for this hidden realm and for the coasts far away. For now, stay with that image, a vast, unseen ocean, waiting in the dark, just beneath where we stand. Ross and Filchner Roan, the giant, sleeping platforms. So let's stay with that ocean a moment longer, and let it expand in your mind. Make yourself comfortable as we widen the view, because that hidden water is not just a narrow channel under one glacier, but a broad, dark sea stretching beneath platforms of ice the size of nations. We often picture Antarctica as a single white mass, a solid shield of frozen land. But along its edges there are places where the ice loosens its grip on the rock and begins to float, forming shelves that extend far out over the ocean. The Ross Ice Shelf is the largest of these, a calm, pale plain on the surface, yet underneath it hides a cavity as long as a country and as deep as a mountain valley. On the other side of the continent, the Filchner Roan Ice Shelf spreads out in a similar way, a twin giant, together with Ross forming two immense gently flexing platforms that fringe the cold heart of the South Polar world. From above, they look almost featureless, just subtle ridges and faint lines where crevasses have healed over the years. But beneath, the story changes. Now, picture what happens when that thick ice lifts from the bedrock and begins to float. Sea water flows in, channels carve upwards into the ice, and the pressure of hundreds of meters of frozen weight shapes the ocean into long, low caverns. In some places, under Ross the ice is more than a kilometer thick. Under Filchner Roan, the floating roof stretches hundreds of kilometers inland, covering deep basins and hidden ridges we know only from the echo of radar pulses. And yet, for all that size, we have barely been there. We're going to talk about worlds that could swallow fleets of ships, but that have only a handful of human-made holes reaching down into them. A few carefully drilled boreholes in Ross, a few in Filchner Roan, each one a narrow temporary throat through which hot water, cables and small instruments descend before the ice slowly closes again. A small under-ice robot like Icefin has swum in these black waters, tracing short paths under the shelf, but compared to the space available, those paths are like a single thread laid across a continent. What those rare visits have shown is both reassuringly ordinary and quietly astonishing. Instruments record temperature and salinity profiles, revealing layers of slightly warmer, saltier water rising to kiss the ice from beneath, and colder, fresher meltwater flowing back out along the ceiling of this submerged world. We see evidence of melt and refreeze, where ice has been eaten away and then rebuilt into glassy crystal forests that hang from the underside of the shelf. Cameras lowered all the way to the seafloor sometimes find soft sediments, stones dropped by the glacier long ago, and every so often, a pale starfish, a cluster of tiny anemones, or a film of microbes waving in the slow, deep current. But these are pinpricks of knowledge in an enormous, dark map. Most of the sub-ice cavities under Ross and Filner Rhone have never been directly visited, never been imaged by a passing robot, never even heard the faint hum of our machines. We infer their shapes from gravity measurements and radar. We sketch the flow of water with computer models, yet the detailed bends of channels, the roughness of the ice ceiling, the true richness of life on the seafloor all remain largely hidden. Not because we lack curiosity, but because the combination of distance, thickness, pressure, and the risk of contaminating these cold, isolated places turns every new hole into a major expedition. So when we stand on the surface of these shelves, we are really standing on roofs, enormous roofs stretched over silent oceans that have been in the dark for thousands of years. Follow me, just in your imagination, as we move from these quiet giants toward a smaller, more troubled shelf, where the water is warmer, the ice is thinner, and the story unfolding beneath the surface is far less stable than it first appears. Larsen B. When the roof suddenly vanished, toward a smaller, more troubled shelf, where the water is warmer, the ice is thinner, and the story unfolding beneath the surface is far less stable than it first appears. That smaller shelf has a name you may have heard in passing, almost like a warning that drifted through the news and then was gone. Larsen B. For thousands of years it was simply there, a quiet white balcony of ice attached to the Antarctic peninsula, a frozen roof stretching over a cold, dark arm of the sea, holding back the glaciers that flowed down from the interior. Then, in the austral summer of 2002, that roof vanished with a speed that still makes scientists pause. We often picture ice as slow, patient, almost unwilling to change, but Larsen B reminded us that under the right pressure and warmth, even ancient ice can move like glass shattering. In just a few weeks, an area of ice shelf larger than a major city broke apart into a chaos of drifting fragments, the surface cracking, collapsing, and dispersing into the open ocean. Now, picture what happens when a ceiling that has been in place for millennia suddenly disappears, and a world that has only known darkness is exposed to the sky. Beneath Larsen B, the ocean had been sealed away, a hidden place where faint, ghostly light from above never arrived, where life, if it existed, relied on slow-falling particles from the ice and on chemical energy rising from the deep. When the shelf disintegrated, that covered water column and the seafloor below were, for the first time in thousands of years, bathed in direct sunlight and open to the air, wind, and waves. Imagine the first rays of light reaching animals that had never seen day, and currents suddenly stirring sediments that had lain undisturbed for centuries. Scientists understood that this was a once-in-a-lifetime opening, and they moved quickly, sending ships and instruments into the newly revealed bay before the system could settle into a new normal. They found sponges, starfish, and delicate filter feeders that had adapted to a world of permanent night, now sitting under a bright surface, their cold, stable environment replaced by one that was more variable, more connected to the wider ocean. It was as if a deep cave had lost its roof, and the inhabitants were left blinking in the sudden light. But Larsen B's story was not just about ecosystems. It was also about what happens to the glaciers that once flowed into that shelf. Make yourself comfortable with the idea that an ice shelf acts like a brace, a gentle hand on the shoulder of the ice behind it. When the brace is removed, the glaciers feeding it can suddenly slide faster. After 2002, the glaciers that had been held back by Larsen B sped up dramatically, in some cases doubling or tripling their flow, pouring more ice into the ocean and adding to sea level rise. That's what a glacier is, in part. A river of ice responding to the loss of support at its edge. So Larsen B became a quiet turning point, a reminder that the hidden world beneath these shelves can change not slowly, but abruptly, and that our clearest views sometimes arrive only after something breaks. As we look toward other shelves that are thinning now, we're going to ask, what else is poised on that same fragile edge, waiting for its roof to fail? Thwaites, peering under the Doomsday Glacier, Larsen B showed us what happens when the roof gives way. Now, follow me a little farther along the edge of West Antarctica, to a place where the roof is still holding, but only just. Here lies Thwaites Glacier, a vast, creaking body of ice that people sometimes call the Doomsday Glacier, not because it wants anything from us, but because of what might happen if it lets go. We often picture a glacier as a frozen wall, still and solid, but that's not what a glacier is, and Thwaites least of all. It is more like a slow river of ice, hundreds of kilometers wide, draining a deep basin of the Antarctic ice sheet toward the sea. Its floating shelf acting as a kind of cork that holds back ice far inland. If that cork were to fail, sea levels around the world could rise by tens of centimeters, and over longer spans of years, it could help unlock neighboring basins that together hold enough ice to reshape every coastline on Earth. So scientists have gone to one of the harshest places on the planet to see what is happening beneath its shelf. Imagine standing on a flat, white plain of ice, knowing that hundreds of meters below your boots there is black ocean water flowing in darkness. In 2019 and 2002, teams melted narrow shafts through this cold roof with hot water drills, racing the pressure of the ice and the refreezing walls, and then lowered a slender, torpedo-shaped robot called Icefin into the cavity below. Icefin is small enough to slip through a hole barely wider than a person, yet strong enough to endure the deep crushing pressure and the constant threat of drifting ice. Once it left the light at the surface, it swam out under the shelf, shining its own lamps on the underside of the glacier, measuring temperature, salinity, and the slow motion of the water that eats at the ice from beneath. What it saw was not a smooth ceiling, but a rough, sculpted world. Instead of a flat base melting evenly, the ice was carved into channels and terraces, with ridges and pits where meltwater had focused and then refrozen, like frozen rivers running upside down. Some places were melting faster than models had predicted, others slower, creating a complex patchwork rather than a simple, steady retreat. Now picture what happens when slightly warmer deep water, the circumpolar deep water that circles Antarctica, finds its way into those channels and toward the grounding line, that hidden boundary where the glacier lifts from the rock and begins to float. Measurements showed that this warm water is indeed reaching critical grounding zones, thinning the ice where it is most vulnerable, loosening the glacier's grip on the bed beneath. We're going to remember that, because it means that the real decision points for Thwaites are happening out of sight, in a cold, dark place we can barely touch. Even here, at one of the most intensely studied sites on Earth, Icefin and its cousins have explored only a tiny fraction of the cavity, a few narrow corridors in a space that stretches for hundreds of kilometers. Make yourself comfortable with that scale for a moment. We have exquisite detail from a handful of tracks and almost nothing from the vast distances between them. It is as if we had sent a single submarine to map an entire ocean and then tried to predict every current, every hidden ridge, from its lonely path. We stand at the threshold of understanding Thwaites, our instruments brushing the edges of a system whose deeper reaches remain in shadow, and as we turn to other shelves and other hidden seas, the question quietly grows sharper. If this is what we find in the little we've seen, what waits in all the places we haven't reached yet? Hidden rivers, shifting grounding lines. So we leave Thwaites for a moment, that one troubled outlet we've just brushed with our instruments, and we widen our view to the rest of the frozen rim of the continent, because what we found there is not an exception, but a hint. Make yourself comfortable and follow me a little further inland, away from the bright white surface we know, into a world that almost never sees direct human attention. We often picture Antarctica's ice as a single solid block, a clean sheet of frozen water pressed down on rock, but the more we listen with satellites and radar, the more that picture falls apart. Thin pulses of radio energy, sent from aircraft or from the ice itself, reflect off hidden layers and return with tiny delays, and from those delays, scientists have drawn maps of rivers that no one has ever seen. Narrow, branching threads of meltwater flowing along the base of the glacier, then disappearing into the dark cavities beneath the ice shelves of the coast. Under the Ross, under Filchner Rhone, under Thwaites and its neighbours, there are whole drainage basins, hundreds of kilometres long, quietly feeding the under-ice seas. Now, picture what happens when that water arrives. It is fresh compared to the salt ocean beneath, and often close to the freezing point, yet still slightly warmer and lighter than the coldest deep sea water. As it pours out from beneath the grounded ice, it rises in slow plumes, like breath in winter air, changing the way the hidden ocean circulates, stirring layers that might otherwise stay separated for years. In some places, it helps create narrow melt channels carved upward into the shelf. In others, it caps the sea with a fresher lid, steering where warmer, saltier water can reach the ice. That means a river far inland can decide where the shelf melts fastest at its edge. A small change in flow, caused by a warmer summer at the surface or a shift in pressure at the bed, can redirect these under-ice currents, focusing melt in new zones, starving others, and over decades reshaping the ceiling of this cold, roofed-over sea. The world beneath is not just passively eroded by the ocean, it is being plumbed and rewired from above by the ice sheet itself. At the same time, another quiet boundary is on the move. The grounding line, that invisible place where a glacier stops resting on rock and starts to float as an ice shelf, is not fixed. As warm circumpolar deep water works its way under West Antarctica, eating at the underside of the grounded ice, that line can retreat inland, sometimes by kilometers, in a single human lifetime. When it does, ice that once sat pinned to the bed becomes buoyant, the shelf thins and stretches, and the hidden ocean beneath it suddenly grows taller and wider. This retreat can destabilize the shelves that act like corks in the necks of deep basins, letting the inland ice flow faster, but it also redraws the shape and volume of the under-ice ocean itself. Cavities lengthen, new passages open between once separate pockets, old pathways close as ridges lose contact with the ice above. River outlets that once met the sea at one depth now spill into a deeper, more open space, changing how their fresh water is mixed and where melt is focused. The map we might sketch of this world today would already be slightly out of date by the time we finished drawing it. So when we talk about the ocean beneath Antarctica's shelves, we are not describing a static chamber entombed in ice, but a restless, evolving system where river pathways shift, grounding lines creep, and the ceiling itself rises and falls. In slow motion, over years and centuries, the continent is redrafting its own coastline from the inside out. And as we try to imagine what this means for the life and the records hidden in that dark water, we run into a deeper problem. How do you explore a moving target that you can barely reach even once? Listening to the ice, seismic whispers, and tiny tilts. So instead of chasing the ice with ever more elaborate drills and restless machines, we slow down and do something quieter. We listen. In a cold, white place that seems almost silent on the surface, scientists lay out instruments that are built not to cut into the ice, but to feel the faintest tremors passing through it. We often picture exploration as loud and dramatic, with spinning blades and bright lights and hurried voices on the radio. But scattered across some of Antarctica's great shelves are small seismometers, each no bigger than a lunchbox, half buried in snow, simply waiting. They listen for the sharp crack of a crevasse opening somewhere deep beneath our feet, for the long, low groan as a glacier flexes under its own weight, for the muffled thunder of distant icebergs breaking free at the front of the shelf. They even hear the ocean itself, as waves far out at sea send rhythmic pulses through the floating ice, like a slow planetary heartbeat. Now picture what happens when we pay attention not just to the loud events, but to the tiniest motions. Along the grounding line, where the ice stops resting on rock and begins to float, the shelf tilts and relaxes by millimeters as tides rise and fall, as water slips in and out of the dark cavities beneath. Sensitive tilt meters and the seismometers themselves can pick up these almost imperceptible shifts in pressure and balance, revealing where the ice is firmly attached to the earth, where it is completely afloat, and where it is just barely touching down on hidden bumps and ridges below. It is a kind of cartography made from whispers. Instead of drawing coastlines from photographs, we infer them from how the ice rocks back and forth over hours and years. A small extra tilt at high tide might mean a deep channel under the shelf. A sudden change in the pattern could signal that a patch of ice has lifted free, or that warm water has carved a new path into the deep. Far out under the shelves, in a world we can barely enter, other instruments move even more slowly. Ocean moorings stand like invisible masts on the seafloor, lines of sensors rising up toward the under-ice ceiling, measuring how cold or warm the water is, how fast it flows, how much salt and meltwater it carries. Shaped like slender torpedoes with wings, adjust their buoyancy to sink and rise, feeling their way along the seafloor and under the shelf edge, steering by tiny shifts in pressure, instead of by GPS signals that cannot reach through hundreds of meters of ice. Follow me for a moment and make yourself comfortable with this different kind of exploration, because it is a gentle pattern interrupt from the heroic image of drilling through a kilometer of ice in a single season. Here, patience is the main tool. A seismometer may sit through long polar nights, recording nothing more dramatic than the soft hum of distant waves. A mooring may wait for years before a tongue of warmer deep water finally brushes past, announcing itself not with a roar, but with a change of a fraction of a degree. Taken together, these quiet instruments become a vast hidden observatory spread across the ice and ocean, listening to a world we can almost never visit directly. They allow us to slow our thoughts, to feel the ice shelves as flexible floating bridges that bend with tides, shiver with storms, and thin from below as unseen currents work at their foundations. And as we begin to hear this faint music more clearly, another question emerges. If the ice and ocean are already speaking to us in vibrations and tilts, what else might be alive and waiting in that deep, dark water, leaving traces just as subtle and just as patient? Dreams of future under-ice explorers. So, make yourself comfortable again and let your attention sink back under the ice into that hidden music of tilts and tremors and slow creaks we were just listening to. Because we're going to let the imagination move a little farther than the instruments can and see what kinds of quiet explorers might someday share that deep, cold water with the animals already living there. We often picture exploration as one heroic machine, a single bright vehicle inching forward through the dark. But imagine instead a kind of gentle snowfall in reverse, swarms of small, intelligent robots, released through a single narrow borehole in the shelf, drifting downward together like curious fish, then fanning out beneath the ice roof until their tiny lights are just distant, moving stars in a black sea. Each one could listen for currents, taste the chemistry of the water, feel the pressure changes near a melt channel, and then murmur its findings back to the others in a slow underwater conversation. Now, picture what happens when we remove even the last thin tether of cable, and these explorers are allowed to roam for years at a time. Engineers already sketch ideas for autonomous vehicles that could slip under an ice shelf, recharge at small docking stations frozen into the underside of the ice, leave behind sensor packages like little weather stations for the ocean, and gradually stitch together a map of caverns, grounding lines, and hidden ridges that no human eye will ever see directly. Could a network like that watch a vulnerable shelf such as Thwaites as it thins from below, patient and unblinking, long after our brief field seasons have ended? From above, other dreams move more slowly. Some researchers imagine melt drills or cryobots, long warm cylinders that would descend through hundreds of meters of ice by gently melting it, refreezing a clear, sterile tunnel behind them as they go. At the base, they might unfold small fins or screws, transform into simple under-ice swimmers, and then travel horizontally beneath the shelf, in the same spirit as probes proposed for Europa and other icy worlds, where an ocean hides beneath a frozen shell, not unlike this one at the end of the Earth. All of this, of course, runs into the hard edges of reality. Power must last for years in a place that never sees the sun. Communication has to pass through thick ice without disturbing the very environment we wish to observe. Machines must survive crushing pressure, shifting ice roofs and the slow abrasive touch of sediments carried by the water. And beneath it all lies an ethical question. If these are fragile little-known ecosystems, what right do we have to fill them with complex machines, however careful we try to be? So for now, it is better to let these ideas remain what they are: quiet dreams, sketches in notebooks, gentle animations on a researcher's laptop while storms rattle the field tent above. They are not blueprints waiting to be built tomorrow, but possibilities we can visit in thought, the way you might wander through an empty, echoing cathedral before any stones have been laid. If we slow your thoughts just a little and follow me one step further, another question appears at the edge of that dream. When we finally do send more eyes and ears into this world beneath the ice, what kinds of lives might already be watching us arrive? Antarctica as a training ground for other worlds. If those hidden eyes exist, they are staring out into a darkness that feels strangely familiar, because somewhere else in our solar system, other oceans may be waiting under their own roofs of ice. We often picture alien worlds as red deserts or stormy gas giants, but some of the most promising places for life are, in a quiet way, cousins of Antarctica's deep sub-ice shelf seas. Imagine you could rise up, far above the clouds, and drift outward from Earth, carrying with you the memory of this cold, creaking continent. You pass Mars, you pass the wide belts of rock and dust, and you arrive at Jupiter, where a small striped moon called Europa circles through intense radiation, its surface a cracked shell of ice. Now, picture what happens if you could lift that shell like a lid. Beneath it, scientists suspect, lies a global ocean, kept liquid by tidal flexing and pressure sealed away from sunlight for perhaps billions of years. Farther still, around Saturn, another icy moon, Enceladus sends thin plumes of water vapor and ice grains into space from fractures near its south pole. Those plumes are our clue that, under its frozen crust, there is also a deep ocean, dark and pressurized, brushing against rock, rich in chemical gradients that could, at least in principle, feed life. In both places, the water never sees the sun. It sees only the slow, patient glow of internal heat. Now we look back at Antarctica and realize that, on our own planet, we already have a small, fragile version of that same arrangement. Under shelves like Ross or Filch-Nérone, seawater flows in black corridors between rock and ice. Under hundreds of meters of frozen ceiling, at pressures that would crush ordinary diving gear. When we drill through that ice with carefully sterilized hot water systems, when we lower slender robots like Icefin into the gap, we are not just exploring a remote earthly place, we're rehearsing for Europa and Enceladus. The techniques we refine here, melting narrow shafts without contaminating what lies beneath, navigating in a world with no GPS, whispering data back through deep ice, quietly shape the designs of future space probes and cryobots. We're going to need machines that can melt down through alien ice, survive in a black ocean, and search for life without erasing it. Antarctica becomes, paradoxically, both the most distant and the most accessible training ground we have. And there is a deeper implication too. If on Earth, life can cling to the undersides of ice shelves, feeding on chemical traces in cold, slow water, if microbial mats and filter feeders can endure years and years of darkness, then the idea of life in those far-off oceans starts to feel less like fantasy and more like continuity. The same physics, the same pressure, the same deep hidden gradients of energy might be at work. So when we learn how to listen to the faint echoes in Antarctic cavities, to the creaks of ice and the soft signatures of tiny organisms moving in the dark, we're also learning how to listen to the wider universe, training our instruments and our imaginations at the same time. Make yourself comfortable with that thought for a moment, because the next question is even stranger. If we do send those explorers into alien seas one day, what happens if something there has already learned how to listen back? Should we open every hidden door? If something out there might already know how to listen, then we have to pause and ask a quieter question. What does it mean to knock on a door that has never been opened before? Not by us, not by anyone in living memory. Beneath Antarctica's ice shelves, in that cold black water pressed under hundreds of meters of ice, there are places that have been sealed away for hundreds of thousands, maybe even millions of years. We often picture exploration as simple forward motion, as drilling through the ice, lowering a robot and switching on the lights. But now, picture what happens when that first shaft of human-made light spills into a hidden chamber where the only constant has been darkness, slow chemical reactions, and the faint drift of particles from the glacier above. Whatever lives there has evolved under a very specific balance of temperature, pressure, and chemistry, and a single careless intrusion could shift that balance forever. Contamination is not just an abstract worry, it is a physical thing we carry with us. The hot water we use to melt a hole through the ice can bring microbes from the surface world. Drilling fluids, if they are not carefully chosen and filtered, can seep into the under-ice ocean. Even the metal and plastic of a probe can introduce traces of modern life into a place that has never met it before. Imagine a microbial mat beneath the Ross ice shelf, slowly growing in the dark for tens of thousands of years, and then meeting one stray surface bacterium that outcompetes everything around it. Because of that, scientists have built strict protocols that almost feel like rituals of humility. They sterilize every hose and nozzle, they use ultra-clean water instead of chemical drilling fluids, they flush and test and repeat, and they accept that each of these steps slows them down. We're going to spend days, sometimes weeks, just preparing the system before a single instrument touches the deep water. Not because we are indecisive, but because the cost of haste could be the quiet erasure of an entire unseen ecosystem. This is the tension we live inside, the pull of knowledge and the weight of responsibility. We want to understand how these under-ice worlds work, how melt channels carve the base of a glacier, how life survives without sunlight, how changes here ripple out to coasts all around the Earth's surface. At the same time, we know that the very act of looking can change what we see. So we learn to slow our thoughts, to accept fewer holes in the ice, smaller samples, gentler instruments. Follow me for a moment into that idea, because it reaches beyond Antarctica. If we treat these places as practice for visiting oceans on other worlds, then maybe the most important skill we develop is restraint. Make yourself comfortable with the possibility that some doors should open only a crack at first, and that patience is part of exploration. In the next part, we'll ask what happens when the ice itself starts to open those doors for us, faster than we ever intended. The shelves as guardians of the coasts, so when the ice begins to open those doors on its own, faster than we ever planned, the question quietly shifts from whether we should go in to whether we're ready for what comes out. Make yourself comfortable for a moment and slow your thoughts, because we're going to follow that change from the hidden world beneath Antarctica's shelves all the way to the shorelines where people live. We often picture an ice shelf as just a flat, white platform, a frozen balcony at the edge of the continent, but in the language of ice, it is more like a hand spread out over the ocean, holding back the deep weight of the glacier behind it. That's what a glacier is, a slow river of ice pushed outward by its own immense pressure, always wanting to slide downhill and outward toward the sea. The shelf, floating yet attached, braces that flow, and this quiet bracing is what scientists call buttressing, a kind of invisible support. Now, picture what happens when warmer ocean water slips into the dark space beneath that floating ice, especially in places like West Antarctica, where currents of circumpolar deep water can reach far under shelves like Thwaites or Pine Island. From the surface, nothing seems to change, but below, the under-ice ceiling begins to melt, not in a dramatic collapse, but in thin layers, in sculpted channels, year after year. The shelf loses thickness, loses strength, and that hand that once held the glacier firmly begins to relax its grip. When that buttressing weakens, the glacier behind responds in the only way it can. It flows faster. Ice that once took many centuries to reach the ocean can arrive in mere decades. It is still just frozen water becoming floating icebergs and meltwater. But the timing changes, and in sea level, timing is everything. As more ice crosses the line where it starts to float, it eventually adds to the volume of the world ocean, raising the average level of the sea not in a sudden wall of water, but millimeter by millimeter, year after year, century after century. This is where that cold, distant place beneath the shelves reaches into our own world. A thinning shelf in the Amundsen Sea sector can, over time, influence flood maps in Miami, building codes in Rotterdam, and the future of low-lying nations like Bangladesh or island states scattered across the Pacific. It feels almost unreal that a hidden cavity under hundreds of meters of ice can help decide whether a coastal neighborhood must build higher walls, or retreat, or reinvent itself entirely. But that is the quiet arithmetic of ice and gravity on a turning Earth. And yet, this is not a single looming catastrophe. It is a long conversation between ice and ocean, spoken in small changes of temperature, in subtle shifts of pressure at the grounding line, in the slow speeding up of glaciers that few eyes will ever see directly. Follow me into that thought. Right now, as you listen, black seawater is touching the undersides of shelves we have never visited, reshaping the future outline of continents in ways we are only beginning to measure. In the next part, we'll go even closer to those vulnerable corks of West Antarctica and ask what happens if one of them finally gives way. A slow recap beneath the frozen ceiling. So before we move closer to those fragile corks, let's pause for a moment and look back over the world we've been slowly unfolding together. Make yourself comfortable and let the pieces of this cold puzzle drift past again, one by one, like flows of ice turning in a dark current. We began far above, on the white surface, where snow falls as something soft and weightless, and then, over years and years, is pressed down by its own weight until it becomes a river of ice. That's what a glacier is. Not a frozen statue, but a slow, heavy flow creeping toward the sea. Now, picture what happens as those rivers reach the coast and spread outward into shelves that float, hundreds of meters thick, over black seawater that no sunlight has ever touched. Beneath those shelves, we followed warm, salty currents as they slipped in from the deep ocean, hidden under the ice like thieves in a dark hallway. We watched them rise against the underside of the shelf, melt it from below, and carve long, secret channels and caves that no human eye has seen. We often picture Antarctica as a solid block of white, but under the ice shelves it is more like a lacework of cavities, grounding lines, and over-deepened basins, an entire oceanic landscape sealed away under a frozen ceiling. Down in that night, we caught brief, careful glimpses of life, thin microbial mats clinging to the sea floor, turning chemical gradients into energy, filter feeders fixed to lonely rocks, opening their delicate arms into a current that has never known daylight. Strange ecosystems that have adapted to a world where the pressure is immense, the cold is constant, and the only rhythm is the slow flexing of ice above. To reach those places, we reminded ourselves we have had to become patient and precise. Radar pulses sent from aircraft and satellites, sketching the shape of the hidden bedrock and the deep cavities beneath the shelves. Hot water drills on the surface, boring narrow temporary shafts through hundreds of meters of ice before the cold closes them again. Slender robots like Icefin, lowered carefully through those short-lived windows, swimming for a few hours under the shelf, sending back images and measurements from a world that might as well be another planet. And yet, for all of that, we are still mostly standing on the roof. We have outlines and hints, cross-sections and echoes, but the rooms beneath our feet remain largely unseen, their corners and corridors still guessed at rather than known. What if almost everything we've imagined there is only the first rough sketch? So, for now, let the details soften. Let the rivers of ice, the floating shelves, the black water, the pale creatures, and the quiet machines blur together into one calm sense of vastness beneath the Antarctic ice. As we move on, we're going to carry that feeling with us and gently ask what happens when this hidden world begins to change the coasts of the world above, drifting away over the hidden seas. So, for now, let the details soften. Let the rivers of ice, the floating shelves, the black water, the pale creatures, and the quiet machines blur together into one calm sense of vastness beneath the Antarctic ice. As we move on, we're going to let that vastness become quieter still, not a puzzle to be solved, but a distant, steady presence at the edge of your awareness. Make yourself comfortable wherever you are. Maybe you're lying down, maybe you're sitting in the dark with only a small glow for company, and the sounds of the day have finally begun to fade. Follow me, just for a moment longer, as we let this hidden world become a kind of gentle backdrop for your own breathing, your own thoughts, your own slow drift towards sleep. Imagine that we are no longer standing on the coast or at the edge of a research camp, but drifting high above the white expanse of an ice shelf, as if the whole cold roof of this world were passing silently beneath us. Below, the Ross or Filchner Ronne shelf stretches out like a frozen sea, flat and pale, but under that calm surface hundreds of meters deep, black water moves in long, unhurried currents. Now, picture what happens as your gaze softens and you look through the ice, as if it were glass, down into that dark ocean beneath. We often picture ice as still and simple, but here the shelf is slowly flowing outward, year after year, while the sea beneath flows inward, carrying slightly warmer deep water that nibbles at the base of the glacier from below. Channels widen, caverns open, the grounding line creeps, yet from where you float, everything feels almost motionless, as if the entire place were breathing on a timescale far longer than a human life. Let your own breathing match that sense of slowness. In, like the tide moving under the ice, and out, like the shelf easing toward the open sea. You don't need to remember the names, or the numbers, or how many meters thick the ice might be. You can let all of that go. Let the facts fall away and settle, the way snow settles on a quiet field, layer after layer, until the sharp edges of memory are rounded off and softened. If a detail slips away, that's all right. It can rest there, beneath the surface of your thoughts, under a light white cover. As you breathe, imagine that the slow creak of ice and the deep hush of water are keeping time for you, like a clock too vast to see. The pressure in those hidden caverns, the darkness under the shelves, the patient unseen life clinging to rock and ice, all continue whether we pay attention or not. Not because we are watching, but because that's what a glacier is. A long, quiet conversation between ice, ocean, and earth. So, if your eyelids grow heavy, you can let them close. The hidden world will keep moving in its own rhythm. The shelves will keep drifting. The deep water will keep circling under the cold roof of Antarctica, with no need for us to supervise. If you drift off, you can let your dreams wander under the ice, through tunnels and chambers no light has ever reached, following those slow currents into places we have not yet seen, and may never truly explore while we're awake, keeping this gentle corner lit. So as you float there, either on the edge of sleep or already drifting somewhere beneath the ice in your mind, this is where we gently turn from Antarctica's hidden world to the small, quiet world we share here together. Not the world of continents and currents, but this little cold, calm place on your screen, where we slow our thoughts and follow questions down into the deep. Journeys like this one, that take their time and move at the pace of a glacier rather than the pace of a headline, only really exist because a small community chooses to stay, not millions rushing past in a bright blur, but a few thousand, or a few hundred, who make yourself comfortable, let the noise of the day fall away, and decide that it is enough simply to listen to ice and water and years unfolding under the surface of the earth. We often picture the internet as something fast and restless, always refreshing, always louder than before, but there are still corners where the light is softer and the pressure to react is low. And that is what we're trying to keep alive here. When you tap like or subscribe or leave even a few quiet words, you are not just feeding an algorithm, you are helping this gentle corner remain visible beneath the glare. The way a faint aurora still shows up against a bright city sky if enough people remember to look up. If you feel like speaking, you might tell us where in the world you are listening from, or whether you made it all the way to the end awake, or if you slipped under somewhere back near the grounding lines and melt channels, and are only hearing this now in a soft, half-dreamed way. It can be a single word, a city, a coastline, a simple, still here, that lets the rest of us know this quiet company stretches farther than we can see. And if you prefer to remain silent, that is perfectly all right. Your presence is already enough. Just by letting this play in the background of your evening, or your night shift, or your long flight across the dark, you are part of the listening that keeps this kind of slow exploration possible. Not everyone beneath a glacier has to make a sound. Some forms of life endure for years in the dark, simply by being there. So for now, we'll let this expedition rest, here at the edge between the known map and the blank spaces under the ice shelves. And we'll say a soft farewell, but not a final one. We're going to keep returning to these hidden worlds, above and below the surface of our planet, following the cold water where it leads. And when you're ready to travel again, you can just press play, slow your thoughts, and follow me back into the dark. One last glimpse beneath the ice. So before we let the screen go dark, let's return just once more to the world we've been hovering above all this time. Not the white map of Antarctica that we often picture from space, but the other one, the one turned upside down in our minds, where a vast black ocean lies beneath a continent of ice, stretching away in every direction, farther than our lights, farther than our cables, farther than our courage can yet go. Follow me, just for a moment, down through that ice, past the last snow crystals, past the blue, past the places where cracks glow with borrowed daylight, until even the memory of the surface fades. Now, picture what happens when the ice shelf finally gives way to open water, and the ceiling above you becomes a rough, frozen sky, and below you is only depth and pressure, and a cold so complete it feels almost like silence made into a place. Imagine, hanging there in that darkness, a single small robot, or a lonely sensor the size of your hand, glowing faintly green or gold. Its light reaches only a few meters, then dissolves into the black. Around it, the water has been here for years, maybe centuries, circulating slowly under the glacier roof, brushing past the grounding line where the ice still grips the rock, listening in its own quiet way to the creaks and sighs of the ice above. There are no crowds here, no traffic, no noise but the soft hiss of ancient currents, and the occasional distant crack as the shelf shifts its weight. The seafloor beneath might hold sponges and filter feeders, clinging to rock that hasn't seen the open sky in more than 100,000 years. Or it might be empty mud. We don't know. Our little light just waits, recording tiny changes in temperature and salt, sending back a thin trickle of numbers that we turn into stories about a hidden world we can barely touch. For now, almost all of this will stay in shadow, traced only in radar echoes, in the faint reflections of sound waves, in the careful inferences of maps drawn from far above, not because we've failed, but because this is how the Earth reminds us that some doors open slowly. There is a quiet kind of beauty in that, in allowing parts of our own planet to remain partly veiled, not as secrets kept from us, but as mysteries we are not yet ready to disturb. So when you need calm, or wonder, or just a place to let your thoughts slow their pace, you can make yourself comfortable and come back here in your imagination to this deep, cold ocean under the ice shelves, where the lights are few, the distances are vast, and the questions are larger than our answers. And when you want to listen again, to sink back beneath the surface with us, you know where to find this channel, and you might find that the next time we meet, the ice has shifted, the water has changed, and the world beneath has something new to whisper in the dark.